So today I give you Sawyer X, Perl developer, public speaker, project leader for the Dancer web framework, 2015 White Camel Award recipient, and in his own words, failing bio writer. Sawyer, take it away.
I've written it. Before I start, I actually want to say my first YAPC was in Pisa, in Italy, and I attended one of my first talks. It was about Devel NYT Prof. Tim Bunce was giving the talk, and I was on the IRC channel for YAPC, and I really wanted to ask a question, but I was too nervous, and I asked someone if they could ask the question for me, and you raised your hand, Mois, and you asked that question for me. And I owe you a drink, but I owe you my thanks because it was a really nice experience. As soon as I said, like, I'm too nervous, and he just, I'll ask it.
It was my YAPC, my first YAPC too, by the way.
You are just that awesome. All right, so a few words about me. I work at Booking.com. We're always looking for more people to join us and help us with stuff. If you're interested, come talk to me. I do a lot of Perl. I actually get paid for it, so it's awesome. But I also do a lot of open source and free software. I really enjoy it. I maintain the Dancer 2 web framework. And I started summarizing the Perl 5 core development mailing list. If you're interested and you want to read, the list is actually high traffic, and it's kind of hard to follow everything that's going on there. And it's a continuation of topics. And it's an amalgamation of a lot of different streams of information, so like tickets, threads, whatever. And I kind of summarize all of it. You can find it on blogsperl.org on my user, or the Perl 5 summaries on Twitter, or the Perl 5 core mailing list. I send the summaries there, or the Perl 5 summary mailing list. Send over there too. I don't like writing bios. I'm not very good at it. I'm not really sure how to do it. Okay. So this talk is about Util, and Util was an idea that was started by this email. Jarkko Hitanimi is a core dev in Perl 5, and he wrote an email in September, and he said, so there's this, I had an idea for like a very small micro-optimization. If you take a look at, this is from his email, he said, if you take some variable and you do a ref equals array, what actually happens is that we compile this into a string equal check against a constant, which is the array. So yes, constants are fast, and string equation is really fast as well, but the fact that ref gets a value back of a string and we have to compare it, there's something really weird about this, because Perl itself knows what scalar A or scalar foo is. So this is kind of weird. Instead of just asking Perl, what is it, we're basically saying, could you retrieve some information about it, and I will check what it is. So it's kind of weird. Maybe we can optimize this. So I was thinking about this. So this is foo. And what we have here is a simple check. Would this be a yes or no? Yes, OK. This would be a yes. That's very good. Let's try a different one. What about this? Yes or no? No? OK. That's good. What if I do, there's a typo there. We always do those typos. What about this? Has anyone noticed the change? It's now a hash. It's not an array ref. So what would this be? OK, good. But what if I do this thing over here? What is it now? Right? It's a yes. So what I want to say is that ref actually, we use ref for two different things. And I think it does badly in both situations. The first way that we use ref is to basically ask, is this an array ref of a certain kind of container? Is this a hash? Is this an array? And that works until it's blessed. And that doesn't work. Unless it's regex, and then it's actually blessed into a package called regex, and that's why it's not regex in uppercase, but only uppercase R. So it's kind of weird, right? The other way that we use it is to check, is this a blessed thing? So if we do ref, and it returns a package name, that means it's blessed. So that's the situation in which it doesn't work for non-blessed. But then if we actually bless it to something that also exists as a value returned by non-blessed, like the example I gave, then that breaks too. So basically, both situations we use ref, it sort of works, but not really in both cases. And it's kind of crappy. And I started from looking at it from an optimization perspective, but then I looked at it from a usage perspective. So I thought about solving it in a certain way. If we have something that returns a hash ref, an array ref, some kind of ref, we can just have a function isArrayRef. That kind of fixes the parts on how do I check for it and whether I misspell it, because misspelling happens all the time. Brian Foy actually recommended to save your references and then compare them again. So you could say, I have an empty regex, and I'll save that as a string after doing ref on an empty one, and then I'll compare these two, and then I know that I didn't misspell regex. Which I mean, it's a solution, but it kind of indicates a problem that he just saw a lot of people misspell it. So this solves that, and that's kind of nice, because you can clearly say it is a ref or it isn't. And there are a lot of ways to solve it. One of them is ref util, one of them is ref. They both have their own problems. So I started implementing this. I wrote isArrayRef, isHashRef. Of course, before that, we have scalarref. We have coderef, we have regexref, we have globref, formatref, ioref. I didn't include this. There's also a refref. And it's interesting, formatref actually is not supported by 5.6. So if you're on 5.6, formatref will say, I'm sorry, no. But everything else will still work all the way to 5.6 because it wasn't that complicated and ProBrew is awesome. So what I want to talk about here is explain how this works and show you all of the code. And I implement it in two different ways, and I think both are very interesting. So refutil is written in excess, and people are very, very scared of excess. It feels really scary, but I really enjoy it. I've been doing a lot of it recently. It feels kind of like that. I was looking for equivalent pictures, so I found this one. I like this more. The one I like best is this one. But at the end, you really feel like you have power. Like, it's really, really strong. But the thing is that we have power, we kind of feel like, well, it's very powerful, but at the same time, it's probably very complicated. But sometimes power actually means the opposite. It means simplistic. It means that it's simple to do. It can be elegant. We assume that it's very complicated, it's very low level, we're going all the way to C, this will be a very complicated issue, it will be hard to do, and sometimes it's actually much, 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 much easier. And this is what I'm going to show you. And then I'm going to delve into, no, this can be very complicated if you want it to be. So the reason that I like excess is that when we go down to low level, we actually have data types. Perl itself does have data types as well, just more abstract data types. We talk about SVs, which are scalar values, which is basically the C struct that Perl uses to represent values that we use in the Perl world. And a scalar value, when we talk about data types and, like types, I'll give you an example. This thing, SVT PVAV, this is a way for Perl to indicate a certain type. SVT means SV type, scalar value type, and PVAV is just short for an array value. So this basically means that if I can take any kind of value that I get in Perl and I can compare it to this, I know if it's an array. It's that simple. I can use SV type from excess, which is like a nice macro that goes to the right flag on the SV struct and get that, and tell me what type it is, and I can just compare them and say, well, this thing is an array. It's that simple. Now in Perl, we have the @ sign. People always complain it's not very readable, but at the same time, those symbols, they actually tell us a lot of stuff that we don't have to check for. So visually, you know that the @ is an array. This is how you would know it in the C level. Now, the SV type returns the value, we put in val, but we can also put in something else. If we have a reference, we can use another function that dereferences it, right? SVRV basically says, go to this SV and retrieve what it references. And I give it ref, and then it will return the value inside, and SV type will run on that, and that's how I check if something is an array ref. That now becomes easier than in Perl, because it's an actual simple flag check. It's very, very easy. Of course, we have to check that it's a reference. SVOK is a very simple macro that just says, is it okay to use this thing as a reference? And that checks another flag. And Perl actually caches these, so it's very fast. So this is an entire check that basically asks, is this thing a reference to an array? And it's accurate, and it's fast. It's really fast. I can also put these in parentheses and then say, well, if it is, could you return true? And if it isn't, please return false. And I've just created a complete excess function that implements isArrayRef. It's very simple. I just put the signature on top. So basically, I'm saying return some kind of value, call it isArrayRef, receive some kind of value, and here's the code I want you to run for it. You've just learned excess. It's not that complicated, right? It's pretty simple. Thank you. So when we talk about stuff like that, I mean, it's nice, right? I implemented all of these functions, and then I thought, well, it's not that much faster. And they said, well, it isn't. I actually sent this email. I had a conversation with a lot of core devs about this, and they said, no, it isn't that much faster because Perl is actually really, really fast by running ref and running equal and using constant array. Those parts are not that slow. That's why also Yarko said, that's why I call it a micro optimization, because dude, you couldn't optimize that much. But then someone said, you can have more using custom ops. Perl does this thing that people don't think it does, which is compilation. Perl actually compiles the program and creates an op tree, which is a tree of operations similar to an AST. It's not as good as an AST, but it is already a tree of operations that happen. So a multiplication is an operation, an addition is an operation. A lot of the functions that we have translate to a bunch of these operations that together compose the result of a line of Perl that you wrote. And it compiles them. And with version 5.8, we actually have custom ops, which means that we can create our own ops. So instead of saying, this will be a function that will be translated to like 10 ops, I can make it to a single one. And that's pretty fast. One very interesting optimization that happened recently, Dave Mitchell added to one of the recent versions of Perl something called the multi-op, which is an op that concatenates a bunch of operations at the same time. When have you ever used any kind of variable that was a reference to a reference to a reference, right? An advanced data structure, array of hashes of arrays. And each one of those, every dereference there is an op. The multi-op is basically one op that does all of them at once. It's incredibly fast. You can do your own custom ops, which is even greater. So I thought, well, if we do it as an op, that might be faster. Let's take a look at that. So I'm going to show you how it actually works. We're going to go through it one line at a time. Don't worry. Feel free to raise your hand and ask questions. Hopefully I'll be able to answer them. I can't promise. And if you know more than I do, because some of you definitely do, please feel free to correct me, just like politely. Okay. So the first thing that we do is actually add information about the op that we will have, okay? That is the X op. What we do is use X op entry set, which basically says, once we created a description, an X op, you can add to it a name. We'll say is arrayref X op. You can add description. These are useful for debugging. You don't actually have to do this. But it's very useful if you try to kind of put out all of the ops, or there's an error and you want to know what was, it will tell you the ops. I'll be honest, I've never actually seen this in use myself in my code. I didn't hit a situation where it's like, oh, here it is. I don't know. But it's a good thing. The next thing that we do is very simple. We register the op with Perl. We basically say, hey, could you register? I have this op. We have to give a context of the current Perl. We provide the function that will be the op. We didn't create this yet. I'm sorry, the variable. We didn't create it yet, but we do have the description that we already created. I'll show you all the functions. We'll go through every single line of code. And what we are actually doing now, it's a bit hard to understand at first. What we want to do is have an isArrayRef function that will be replaced by an op during compilation time. So we actually have to create some kind of function. Then we will hook into the compilation phase of that function and just yank it out and put in an op instead in the op tree, which is pretty crazy. But it's not that complicated. So the first thing that we do here is create that function that we will replace. The way that it works is that we can't create the function the way we did before because we have to have a reference to that function in order to add a check to it, in order to add a phase that we can hook up to. So what we do is use newXS proto portable, which defines one and just retrieves a memory reference to it. So this is kind of like creating an anonymous code, like an anonymous function. The CV there stands for code value, which means your code ref. So we create one and we say, let's call it refutil is arrayref. You have to provide the entire namespace. And we say, this will be the implementation for this stub function. We will replace it, but this is the name of it, and this is how you could call it. We have to provide the file in which it was done, and this would be the prototype for it. Because isArrayRef only receives one argument, we can put in a clean prototype, just scalar, that's it. Okay. And then, of course, it was cut. The next part is, oh, was it cut? No, it wasn't cut. Okay, I'm sorry. The next thing that we do is use CV set call checker. What it does is set a hook that we can use to that SV that we created. So create a stub function, we got a pointer to it, and now we say, use this pointer and attach like a before hook to this, which we call a call checker. This would be the CV that we created, you can see that over there, and it's going to run this function, so that's the function that we actually hook up to. This will be our code that does, this will be the before hook implementation. Okay, so this is the code that will be run when someone tries to call that function. It will be run before it, and then the function will be called. What we're going to do is actually remove that function from the before hook and put in our op instead. We haven't defined our op yet. So far, so good. Does anyone have any questions before we delve into like how does this work? Yeah.
Is it normal that you use variables before you declare them in XS? Or did I miss the declaration of this?
I think that the declaration is on top. I'm sorry. The declaration is on top, but I thought that this would be an easier way to explain this.
Okay, thank you.
Yeah. I'm sorry, that wasn't clear. Any other questions? And I want to make sure that you fully understand what's going on. Okay, because like you will write this sort of thing as soon as you exit here, right? It's the homework. Okay. All right, so let's start with seeing that op, okay? Because we declared an op, let's write it. The op, we created a new op variable, we call it isArrayRefPP function, and then what we have is the first thing that we want to do is actually declare the stack pointer. This is what DSP means, declare stack pointer. It actually says, I want to be able to use the stack. Now, what would the stack actually contain? It will contain what I got from the function, so the arguments, and I can also use the stack in order to put things that will be returned to the user. So from my perspective, this is input and output. So in order to use the stack, I have to declare it. And then I say, pop something from the stack, which means get me the first argument, please. And that will be the ref that I got. Same line as before, except this time I'm using different functions, different values to return. Instead of XS return yes, XS return no, I'm using global Perl variables that represent true and false. And those are PLSVS and PLSVNo. Same kind of thing, okay? The macros from XS return kind of do it in an XS-ish way. These are just values. There's a define for them and you can use them, okay? And of course, the fact that I can run this is great, but I have to return it to the user. So if I took something from the stack, I'll put something back on the stack. I'll just add like a push stack. So put back on the stack a value that I just calculated. It will be either this or that. And then we need to tell the Perl compiler that this op is totally fine. We did good, and we return normal. That's it. And then Perl says, OK, the op worked. It's all good. So we now have an op. Hey, this is great. Now what we need to do is, I want to show you the stub function that we have. That's it. The stub function, since we replace it, we don't need it. So what I did was make it croak so I could know if I actually hit it by accident. Now, you should know that this is the first version I wrote. Then I wrote a bunch of tests and broke it. And I understand why. Yes?
How do you write the test for this? In XS or in Perl?
In pure Perl. I just try to, so how do I write a test? I'm sorry, I should be repeating questions if they're not on the mic. How do you write a test for it? The tests are basically just pure Perl that just try to import and try to run the function. But then I realized some of my tests didn't pass and they hit the croak. And I asked a few people this, and the answers I got, well, there's a way in Perl to kind of go around the compilation phase that replaces those functions. You just do it dynamically, and you can do this. Have you ever used can on a thank you. That's so can, when you do can, you're actually dynamically doing this, and you get a code ref, and then you can run it. That will get around all of this mechanism, and it will hit this function directly. So what I did in the later versions was basically make this also implemented. And I used macros so I don't have code duplication. So that's it. But then it works in XS if you go around it, and if you don't go around it, you use it the proper compilation phase, then it's optimized by opcodes. So far, so good? Okay. So that's just the stub function. Now we need to replace it, and we're going to replace it with a call checker. It is this part over here. Okay, this is the entire thing. That's it. So we're getting close to finishing this. I didn't really think it would be this fast. Incredibly fast. I'm very happy. And no one screamed yet. That's nice. Only one person left. So let's start from the top. The first thing that we actually have to do is to call check enter sub args proto. And this is a function that is used to, and I wrote this down because I'm not very good at explaining this, I'm sorry to say. Basically, what this function does is perform fix-ups of the arguments that are part of the enter sub op tree. And it has to go through the subroutine prototypes and make certain adjustments that might be necessary, might not be necessary. It could be the number and syntactic types of arguments. It could be applying context. It could be inserting refgen. So it's like this thing you have to do just to make sure that Pro ran through every cleanup that it has to do and fix-up that it has to do relating to the prototypes or directed by the prototypes. So we just run this, and now we get a new op that we can work with. That it might be the same op, might be a different op, but the enter sub op above, we return a new one. Fairly simple. And then the next thing that we do is we're going to need to get to our function, okay? Now this is traversal in the op tree. So it's like this tree with nodes in it, and we need to start playing with those nodes to go forward in. So the enter sub, I cut in a bunch of lines from here. This is the output of MO concise, okay, be concise. And I cut in the parts that don't matter. What you can see here from 3, 4, and 5. The first one is a push mark. The second one is foo, and the third one is array ref. We actually want the is array ref. So we're going to start traversing this. So if we take the enter sub op, in order to get the next thing in line, we need to go to the next op. You can't go to the next op unless you cast it as a unary op. So first thing that we do is take it and cast it as a unary op, and we go to the first op in it. That's it. Then we're at push mark. That's good. Now we need to go into push mark, and this is a list. Push mark is for list, so this is a list, and we need to make this into, cast it into a list so we can actually go into the list. So let's cast this again. Now we cast it as a list op. And now we can walk in there and say, give me the first one in the list. Then we take this and go to its sibling. So you can see at each point where we are. So the first would be the push mark, then op first will be that foo, then the sibling will be the isArray ref. And we just retrieved the function, isArray ref, from as an op, okay? Not just as like code in the tree or functions, it's an actual op in a tree of operations. We delete all of the instructions after relating to this. Just make it null, there are no other items in it. We create a new op. We set it as a custom op. We give it our isArrayRef pp, which was our function implementing the op. I don't know if that's a good name, but patch is welcome. And we just return the new op. That's it. We just played with the op tree, removing ops, walking around, inserting new ones, creating our own custom ops into our own functions. I think that's pretty neat. So okay, there's a lot of power with this. This is pretty crazy. Custom ops were actually introduced in 5.8, but I'm using two things here. The CV set call checker in order to add before hook, and I'm using the xop entry in order to add some descriptions to the op to make it useful. And those actually only existed since 2010. So you know, there's like this phrase, great power comes some, I don't know. Then what I wanted to do with this is to actually say, well, you know, if you're using, if I don't have these, then let's just use the XS versions. If I have these, let's use it as an op. This was the entirety of the code to do this. So now we support under 2010, and we have it as an XS, which is still pretty damn fast. That was pretty easy, okay? And then if you have the custom op turned off, it just uses this one. And using macros, I don't actually repeat this part over here. This part stays the same whether it's in the op or it's in the XS or whether it's in the stub because you use the can method in order to get to override that compilation phase part. All of those will use the same line of code in order to remove that duplication. They just change the return value. So this one uses XS return because it has to put it on the stack automatically and stuff like that. So okay, speed. People have asked me about speed. Why I wrote it was, well, the main reason was speed, and I was actually disheartened that the first version was slow. It wasn't as slow as the original. It was just a tiny bit faster, like really tiny. So after using the op, this is the benchmark, and this is the benchmark that it's not. You shouldn't use benchmark PM to do benchmarks because it's not very good. You should use dumb bench because it actually does it just better. This doesn't show a comparison against the others. Each one is on its own outliers, iterations, initializers, and so on. And the value here doesn't actually mean it's 3 seconds long. It's 3 seconds fast. It's just how long it took the test to run, which it was a very exhaustive test. And it took this amount of time. The PurePro version, which does ref, took twice as long. So it's twice as fast. That's not bad. And my math is really terrible, but I can see the difference. Then I checked, well, how would ref type compare? Because ref type is a function that gives you, just like the ref util, it gives you the value and not the package. So if it's blessed, it doesn't care. It just gives you the value of it, which is correct. So I looked at ref type, but ref type is 3 times as slow. So it's twice as fast as the correct way, and it's 3 times as fast as the more correct way. Interestingly enough, ref type has one design bug in it, and you can't change that. Ref type returns undef when it fails. It doesn't return empty. That means that if I do a ref type on something that is not a reference, and I compare it, I just compare it in undef. So but the way you usually use ref type is you do ref thing and ref type thing. So the first one, just to make sure it doesn't crash. So this is against, you can see the comparison here, this is just against like the non-safe ref type. Imagine the safe ref type is actually running this twice, like running both. So it would be even faster than a correct ref type, which is the most correct way of doing this. I do want to mention that scalar util has a function called blessed in case you just want to know if something is blessed. Because someone asked me recently, he said, I use ref to know if it's blessed because then I'll get a package name. Well, except when it's blessed wrong. But blessed just tells you yes or no. So yeah, I'm finally done with all of this. It was, I thought it would be much longer to explain. But it wasn't. I want to give a few bits of thanks to several people that really helped me with this. And then we'll have enough time to ask any questions that you want. So the following people were instrumental in this. The first person here, Vikenti Fusunov, is actually a fantastic. I get to work with all of these people, Yarko until recently. And they're all really great people. Vikenti helped me with almost all of it. He knows the core very well and is very quiet, and very few people actually know him. The bottom ones are all core devs, which was really fun to bug them with questions. I want to give a special thanks to this club. We have a thing at work we call P5P Club. And basically, booking allows us to meet every week, as long as we can, for about 2 hours a week to just study the Perl core, which is awesome. Because then we sit and we read C code, we write XS, we play with ideas, we try to fix bugs, we try to play with small feature ideas that are still incubated. We wrote a bunch of stuff that we already released, all of it publicly. We re-implemented in XS the HTTP headers, and it's like tremendously faster than what comes in with Plaque, so you can make your web stack now incredibly faster by just loading it into the memory. So just do a use, everything is now faster. We did it to a bunch of stuff, so it's a lot of fun, and I really enjoy this club that we have. And of course, I can't actually end any talk without thanking the audience. And you stayed through this entire thing. No one died. I saw like one person yawn once, maybe. That's not bad. So I really appreciate this. Since we have a lot of time, I would be happy if you have any question at all. I would be willing to go back, show any piece of code, re-explain it. Any question about its usage, any questions in general, my hotel or flight, whatever you want. So we'll start with that, I guess. All right. Well, yeah.
How did you get here today?
Oh, it's a great question. I took the train and I was late.
Really? You should have walked. Okay, so did you actually release this yet?
Oh, yeah, that's a good question. I wish I paid you. Well, you wish I paid you, I guess. So I did actually do that. Let me see if I have any network here. Am I the right one? I am. Oh, here it is. So this is, it's released, it's version 0.008. The first one was released a while ago. Let me kind of make this a bit more readable. Is this good? Okay. So, yeah, I did. I released it. It's not bad at all. Here's, by the way, is the benchmark in case anyone interested. This is why dumb bench is actually much smarter. But it's a very simple check. Just calling isArrayRef, calling ref type without doing ref before, and calling ref directly, and it runs it this amount of times. And each one of those is actually runs first 20 times, and then as much as it needs to reach this amount of percentage of accuracy. With regards to outliers. So it's a long time. And it runs in a ton of times, and then it just says, this is how long it took each one. And the results that I used, copied verbatim, and some problems with refs and some opinions I have about these. I don't give a shit about overloading. Read-only ties, magic, that's all bullshit. Next. Because like the way they think of it, I should say, things that are not supported actually in ref, it supports these. I explain why I don't support them. But when you do magic and you say, well, this is an array ref that could be used as a hash ref. I think the problem with this is, you didn't ask, but I will still answer. The problem with having overloading is that basically you assume that someone will use it the way that you allowed the overloading to work. So you say, well, I'll allow you to use this as a hash ref. You assume that they will. And you assume that they will in the way that you overloaded. So only the operators that you overloaded. Examples are dates. Date times, there are a lot of these variables for date times that just use overloading. So you could have one variable, bigger, another variable, but then you compare it in a different way and it breaks. Or you put into a type system and the type system checks and fails because the type system didn't check the way that that one thought it would be used. Like, well, obviously you would stringify this. No, it didn't stringify it. It uses references. Oh, then I guess it breaks. So all these things happen, and that's why I think overloading is actually a really, 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 really horrible idea. It's one of the collection of things that we've learned that we should not do. A lot of languages are now getting very excited about this. I hope we stop using it. Magic is very similar. Magic makes it possible to put everything anywhere in any way, but that makes it very opaque and means that, again, you assume that someone will use it in a certain way that you would. So those aren't supported.
So
yes.
Actually, I have a question on my own, and it's very technical. So you mentioned that the naive XS implementation, which doesn't use the opcode magic, was not very fast
Yes.
compared to the pure Perl version.
No, compared to the op. It was slightly faster than the pure Perl.
But it's not like really much faster. And I wonder why, because in my understanding, the XS function doesn't actually get compiled to Perl ops, but to C object code. And so I would have expected that to not have the overhead of the op dispatcher. Why is that assumption wrong?
Is Nicholas laughing good enough? I know. I am not skilled enough to, I'm not knowledgeable enough to answer this. Maybe Nick could, and we could
do
test
you
the mic.
want the microphone?
Subroutine call overhead.
Subroutine call overhead.
as I think they've alluded to enough, oh, I'm not close enough, Nike. Oh dear. Oh, hey, camera. If you do it in pure Perl, I think there's going to be about 4 ops. The op dispatcher is a very tight while loop, and it will call into each op and do it. If you have the XS code, the op dispatcher calls to an op called pp enter sub, which is about 10 screenfuls on any editor because it has to code with all this one. Is the thing we're going to Perl code, if case, that big block of stuff? Oh, it's XS code, that block. And a whole bunch of other things is an L value sub, I can't remember. And eventually, after all this code, it follows a pointer through to your C code, which is really tiny, it runs really quickly and comes back. And now, I can't remember if you have to go through leave sub or not, I think not, but op overhead. There's so much cool stack of marshalling arguments onto a C stack so that it can get through C back to Perl, except this is Perl. Maybe I got a bit of that, but anyway, enter subroutine overhead is massive. So this phrase impedance mismatch is probably quite appropriate here. It's fast once you get into C land, but getting into C land from Perl is slow. And likewise, if you're in C, getting back into Perl land by calling some more Perl code from it is slow. So this is why this is a really cool idea of making it into an op, because you don't have to go through that subroutine overhead. You are in the middle of the op dispatcher. There's that 3 or 4 line of code loop. It just calls into his code. And the amount of code that is run is roughly how much you saw on that slide if you do it as an op. If you do it as a subroutine, I think we'd have to have slides along both walls. That was a long answer.
That was a great answer. Thank you very much. There was another thing to mention is that recently Dave Mitchell did another interesting optimization. The guy who did the multi-op, he actually did another thing recently. He rewrote the entire context stack system. So entering and exiting, what is it, like 30% faster now? Not that bad. Because like how often do you use subs, right? So it's now 30% faster. So that might be, now it might be different. That would be interesting. I haven't tested it yet.
Who wants to write a just-in-time compiler for enter sub? Anyway, are there more questions?
Yeah.
So out of interest, I just did a grep.cpan.me on isArrayRef, and I found data validate type, which also has an isArrayRef, which apparently also does the same thing, checks if something is an arrayref. Did you compare it to that? Or
No, I can't imagine someone implemented this thing as well the way I did. I would be very surprised.
No, it's in pure Perl. I think
okay,
it's
pure Perl. And how does it do it? You know, let's open it. What was it?
The module name is data validate type.
Data validate type. Take a look at that.
Around 235.
Yeah, go into the code is 235. 235.
I'm really risking my my internet here. There we go. 235. isArrayRef. Wow. So allow empty, no blasting, element valid, data dump, sure, is code, defined, and ref. Yeah. And then ref. So it seems like an overcomplication of ref.
And it actually fails if you blast something into the package called 0.
Yeah. Oh, this is, yeah. Oh, okay.
Don't do that.
Yeah. I guess this was probably introduced for a very particular use that he had, or a situation they had. You can see here that he uses ref type, and then he uses overload method to see, are you allowing this to be used as an array, which I really purposefully did not support. So yeah. Yeah, that's it. Does anyone have, do we still actually have more time?
We could talk until 1 because at 1 lunch begins. But maybe we should finish like 5 minutes earlier.
Does anyone have any other questions, thing you would like to ask, or comments that you would like to make about this? We started actually using this recently at Booking. We really enjoy it. Rafael Suarez Garcia, he started sending me links to commits that he did for all the hot code paths they actually saw on the profiler that would be improved by using this, which is very surprising because we assumed that within our stack, which is very big, we assumed the things that would take the most, and they are, like SQL queries or stuff like that, anything that goes to the network, goes to disk, stuff like that, that's usually the biggest overhead, more than like just these small functions. But if you have a very tight loop that uses ref all the time, and we have quite a few, that actually is a noticeable improvement. So something I will probably add is a pure Perl version of this, which will do like a ref and ref type or something like that, just so we could add this to stuff like Dancer or things that are supposed to be also pure Perl if possible. And then if you have this installed, it will just say, well, use these functions instead of the functions that we have, which is the pure Perl. So yeah, we might do that. I think that's about all I have, really.
Thank you very much for the talk.
Thank you.